So hello and welcome in this video. In fact, it is a very short video on two-dimensional discrete random variables. And in this video, basically we will discuss that if we are given two random variables x and y, so these are two discrete random variable. So in this video we are discussing about the independence of x and y. In general we are having that if you are given a two-dimensional discrete random variable, so generally we are having this table which is the probability distribution, and in this table we are having different values of x and y, and also we are having the joint probabilities of for each of this pair. So let's say we are having three values of x and we are having three values of y. So here we are having P11, P12, P13, and let's say P21, P22, P23, P31, P32, and the last one is P33. So in order to show that the independence, so we have to obtain the marginal probabilities for both the random variable. So let us consider or we can extend this table like this. So in this extended rows and columns we are having the marginal probabilities. Okay, so first of all the marginal for x will be this is the first value of x, so corresponding to this we are having these many values here. So when you add, so you will obtain this as p star 1. Why we are putting a star here? Because you can see that here in this column the second suffix is fixed while first suffix is going to change, and similarly we can obtain p star 2, and here we are having p star 3. And on the same line we can obtain the marginal probabilities for different values of y. So here you can see that for y is equals to 1 we are having these many values. So this is p1 star, and so p1 star means this is p11 plus p12 plus p13, and similarly we can obtain p2 star, and here we are having p3 star. Now in order to show that independence of x and y, what we have to show? We have to show that so for independent random variables we are having pij is equals to pi star multiplied by p star j, and this condition should hold for all I j. Means whenever you are multiplying two marginals, means let's say you are multiplying p 2 star which is the marginal corresponding to y2, and let's say p star 3 which is the marginal corresponding to this x3. So when you multiply this p2 star and p star 3, so this product should be coming out same as their joint probability which is p23. So if this type of condition holds for every pair of random variables or every pair of values of the random variables, so we can say that our random variables are independent, otherwise they are not. So let us discuss a problem on this. So here you can have an example. So in this example we are given a table and in this table what we are given, we are having certain values, and we are having two values of x, and three values of y. So we can write these values like this. So here we are having the values of x, which are 2 and 4, and here we are having the values of y, and we are also given the probabilities or the entries for the joint probabilities. So these are 0 0.10, 0 0.15, 0 0.20, 0 0.30, and here we are having 0 0.10, 0 0.15. Now you can first of all we have to obtain the marginals. Okay, so first of all we will obtain the marginals. So again this is the marginal for x, and here we are having the values of x and the corresponding values, corresponding probabilities for these values. So this is the marginal of x here. So as we can see from here that x is having only two values. So the values of x are 2 and 4. Now corresponding to x is equals to 2, we are having three probabilities, 0 0.1, 0 0.2 and 0 0.1. So when you add these probabilities, you will obtain 0 0.4, and here for x is equals to 4, when you are adding these probabilities, so this will be coming out as 0.6. And same we will next obtain the marginal of y. So this marginal is simply contains the values of y, and in the second row we are having their corresponding probability. So this is like this, and here we are given three values of y. So the values of y are 1, 3 and 5, and the probabilities, or you can say the marginal. So for y is equals to 3, we have to add these two values. Okay, so when you are adding, so this is coming out as 0.25, and next for y is equals to 3, we are having the sum of the second row, which is coming out as 0.50, and for y is equals to 5, we are having this as 0.25. So now we have to take the product, means when you are here in the first cell, so this, for this particular cell we are having x is equals to 2 and y is equals to 1. So for x is equals to 2, the marginal is 0.4. Okay, so this is the first value, which is P11. So P1 star is first of all let us complete this. So this is P1 star into P star 1, which is simply the product of the probabilities corresponding to the first values of x and y. So this is 0.4 and multiplied by 0.25. Okay, so this is for the first values. So for x is equals to 2, we are having the marginal as 0.4, and for the first value of y, which is 1, the probability or the marginal probability for y is equals to 1 is 0.25. So when you multiply, you will obtain this as 0.10, which is same as the first value, means the first probability. Now for the second value, we should have the product of the marginals is same as the product of the marginal is same as the joint probability. So here you are having P1 star, means we are having here this probability, means we are at x is equals to 2. So for x is equals to 2, the probability is 0.4, and for p star 2, the probability is 0.5. So when you multiply it, so this is coming out 0.20. And similarly, for this particular entry, you are having the value of y as 5 and the value of x is 2. So for x is equals to 2, here the probability is 0.4. So when you multiply 0.4 with the probability for y is equals to 1, which is 0.25. So this is coming out 0.1. Okay. So this is same as their joint probability. So similarly, we can check that p star I multiplied by pj star, or if we are using the same notation which we have earlier mentioned. So in this case, you can say that pi star multiplied by p star j as pij. So for this particular problem, this property holds. You can easily check. So due to this, we can consider x and y as our independent random variables. So this is how we can check the independence of two random variables which are taking the discrete values, or you can say the two discrete random variables. So that's all for this video. Thanks.